I can see that you have made it this far to the video. You have discovered the greatest math video channel on YouTube. That's right. Congratulations. I'm proud of you. You have made it this far to the beginning of the video. You should be proud of yourself. I'm counting on this video being the one that gets me above 5 views. Okay? 5 views. And then we're going to be trending. All right? So maybe I should leave more often so that I can just view spam my videos, because now I'm just forcing you to watch it. You don't have anything else to do. I'm not even here. I'm not here, so you got to watch the video. This is genius. I don't know why I haven't thought of this earlier, because now you have to. And I'm going to get, hopefully, at least, I mean, how many Algebra 2 students do I have? I have like 58 Algebra 2 students. So if I don't have 58 views on this video, I'm going to know that somebody didn't watch the video. And that'll be a sad day. But anyways, we actually got to do this video because we got to talk about this when I come back. So exponential functions is what we're talking about, new unit that we're going to be rolling out here. So let's get into it. It's not going to be too crazy on the first day of this unit. This right here, y equals a times b to the x, is what we call the general exponential growth or decay equation. All right, so 2 things to know. That is called the base. All right, so there's a little bit of a exponent review here. You got a base, and then you have an exponent. Okay, so the base is the power that, or the base is the thing that's getting raised to a power, and the exponent is whatever that power is. And for, if you're wondering what a is, that's just simply a coefficient. Okay, so that's just a number in front of everything. All right, it could be 5, it could be 1, could be anything. All right, so it's just a number in front of our exponential. So we're going to use this general form to do some graphs today and a couple other things. So the first pretty simple thing that I'm going to point out to you is determining whether or not you are dealing with exponential growth or decay. All right, so it says tell whether each function represents growth or decay. And it's pretty straightforward. You might even remember this from Algebra 1, maybe, perhaps, if you watched those videos. All you need to do is look at the base, so whatever is getting raised to the power, whatever the number is that has the exponent attached to it, you need to look at that and you need to ask yourself, hey, is that thing bigger than 1 or is it less than 1? And if it's bigger than 1, you've got growth. If it's less than 1, you've got decay. So 4 is obviously bigger than 1. So this is growth. Likewise, over here, if I look at this, 2/3, is that bigger than 1 or less than 1? Well, of course, it's less than 1. So we're dealing with decay, all right? And really, by, oh, not a question mark, what? It is absolutely decay. It's not maybe decay, it's absolutely decay. So when I say less than 1, I don't mean negative. You cannot have a negative in these things. And we'll talk about that a little bit more later. I mean if it's a fraction. All right, so here's your rule. If b, the base, is bigger than 1, that means you have growth. All right, if b is less than 1, that means you have decay. And again, we're not going to deal with any negative b's. All right, so that's pretty straightforward rule to start here. 2 more quick ones. 0.25. Think about it. Growth or decay? Yep, you got it. Decay. Because it's less than 1. All right, what about here? 1.5. Growth or decay? Absolutely. You're a genius. It's growth. Why is that? Yes, absolutely, because 1.5 is bigger than 1. All right. So if it's bigger than 1, you got growth. If it's less than 1, you've got decay. All right, so that's the first thing that I'm going to point out. Next thing, we're going to talk about how to graph an exponential equation, okay? So, tells me to graph this thing, f of x equals 4 to the x. Remember, f of x is just a title. Don't let that freak you out. 4 to the x is the function I'm dealing with, and I want to graph that. So, we're going to use a table to do this. We're going to have to plug in some x values, and as we have typically done, we want to try to include some negatives in our x values so that we get a full picture. Get a full picture of what our graph is doing. So we're going to plug in the x values, -2 up to +2. All right. Those are the x values that I'm going to plug into this thing. And I'm going to use those x values pretty much every time that we graph an exponential function. All right. So -2 up to +2. That's what we're doing. So what I need to do is plug in these x values. That was bad. Plug in these x values one at a time in for x. I'm going to see what I get for y. So let's do -2 first. All right, well, that's going to be y equals 4 to the -2 power. Well, you got to think for a minute. What happens when you have a negative exponent? Yes, of course, it has to flip, right? So this is going to be y equals 1 over 4 squared, which is 1 over 16. Okay, so if I plug in -2, I get 1 over 16. And again, all I'm doing is plugging in these x values for x in my function. Okay, so that's what happens if I plug in -2. What happens if I plug in -1? Let's switch colors here. What happens if I plug in -1? Well, my equation is y equals 4 to the x, so it's y equals 4 to the -1 power. Again, negative exponent means I need to flip. So that's 1 over 4 to the first power, which of course is just 1 over 4. 4 to the first power is just 4. So I get 1 over 4 if I plug in -1. All right, the last three values, guys, I bet you could do them in your head. Think about it. What happens if you plug in 0? Well, that would be 4 to the 0 power. 4 to the 0 power. What's that? Well, that was one of our rules, right? Anything to the 0 power is 1. Doesn't matter what it is. It could be 4, it could be 10 million. Anything to the 0 power is 1. So if you plug in 0, you get 1. What about if you plug in 1? Well, that's 4 to the first power. That's easy. It's just 4. What about 2? Well, that'd be 4 squared. And we know that that's 16. Okay. So here's my values. I got my table, so now I'm going to go graph them. I have -2, 1/16. Guys, I don't know where 1/16 is exactly on here, so I'm just going to do my best, and I'm going to say it's really small. Not like that. It's -2, 1/16. It's really small, okay? That's good enough. I'll try to be accurate, but I can't be super accurate here because it's not a great grid to go 1/16, but that's okay. So -2, 1/16. -1, 1/4. A little bit bigger. 0, 1, 1, 4, and 2, 16. 16 is off my graph by quite a bit, right? And that's the thing with exponential functions is that they grow really, really quick. So 16 would be way up, I don't know, like up, oh my gosh. It would be somewhere like up here-ish, right? So I'll just do the best I can. And if I connect the dots, I got a graph that looks something like this, okay? Notice how my line going to the left is above the x-axis. That is never, ever, ever going to actually hit 0, all right? It never will. It's never going to hit 0 because no matter what negative value you plug in, it's always just going to make it a fraction. So it's going to get really, really close to becoming 0, but it's never actually going to be 0, all right? Just a little side note for what's going on in the graph. So to graph these things, we use these x values, -2 to 2, plug them into the function for x, get your graph, and you're good to go. Okay. So why don't you, at this point, pause the video and pick 1, 2, or 3 of all these. I bet you could do all of them. Then you can grab a grid whiteboard out of the back or grab a piece of graph paper and practice. Try to get these things graphed. Okay. And maybe you pause the video, maybe not, but I'm going to run through this one. Oh, whoa, I'm going to run through this one right here for us real quick. Okay, so I'm going to get a table. I'm going to do it sideways because I don't have a ton of room. X, Y. So I'm going to use -2 to 2, those are my x values, and I'm plugging them into 2/3 to the x power, okay? Well, this might get a little weird, so let's come down here and do it. 2/3 to the x power. That's my equation. I'm going to plug in -2. Let's see what happens. Well, that is 2/3 to the -2 power. Well, that's a fraction getting raised to a negative exponent, right? There are kind of two ways you could think about it. You could flip the whole thing all at once, or you could think about our exponent rules from a couple of units ago, and you could raise the top and the bottom to that power. It would be y equals 2 to the -2 and 3 to the -2. I just raise each piece to that power, okay? Now I know I'm going to flip both of those because they're both negative, so I'm going to have to flip-flop these. That's 3 squared over 2 squared, which is 9 over 4. So if I plug in -2, I get 9 over 4. Okay. From here, if you plug -1 in for x, all you're going to have to do is flip these numbers, right? That's all that's going to happen. It's a negative exponent. You're just going to have to flip them. So it's going to be 3 over 2. The other ones we can probably do in our heads. Anything to the 0 power is 1. If you raise it to the first power, it doesn't change. It's just 2 over 3. And if you raise it to the second power, all you need to do is square the top and the bottom. So that's going to be 4 over 9. Okay. So real quick, we'll get our graph. -2, 9 over 4. 9 over 4 is about 2.5. So, oh boy. We're at -2, 2.5. There we go. -1, 3 over 2. That's -1, 1/2. Okay, then we're at 0, 1. 1 2/3. And I can't be super accurate. I'm just trying my best. And 2 4/9. Go from there. Okay, so you can see that this one looks a little bit different than the first one we did. This one looks something like that. Why is that? Because it is decay, right? It's decay because that is less than 1. So now my graph is getting smaller as I move to the right, where before it was getting bigger as you go to the right. Okay, so that's the difference between growth and decay. One of them is getting bigger and one of them is getting smaller. All right. Okay, I have one more type of problem to show you in this video. And it is a problem that looks like this, a modeling type problem. It says write an exponential function in the form y equals ab to the x. Remember, that's just the general form. It goes through the points 2, 3, and 4, 27. So I am given 2 random points. Not really random. They're going to be on this function, but 2 seemingly random points. And I want to write an equation that has both of these things on it. So I want to find the equation for a function that has both these points on it. Okay. So these are the types of problems that I think are pretty fun in math. It's like it's a challenge. You might look at it and think, well, I don't really know what to do. I don't really even know where to start. And I think math does a good job of teaching us to be problem solvers, take initiative, and try to take the pieces that we do have, use the knowledge that we do have to come to a conclusion or maybe come to a piece of understanding that we didn't before, right? So we're using the tools at our disposal. So what do we have? We have this equation and we have these 2 points. Okay, well, you might have in mind a way that you're going to start. Here's what I would do. I'm going to take the equation, y equals ab to the x, and I'm going to pick one of the points to start with. So let's just do the first one. I'm going to call those x and y. I have an x coordinate and a y coordinate on that point. And what I'm going to do is plug in x and y into this equation. Okay? So it's going to look like this. 3 equals ab to the second power. I just replaced x and y with the x and y values from that first point. All right? Once Once you get to that point, you might think that this is a little goofy. Okay, so bear with me, but we're going to get a little bit creative here in order to solve that. What you're going to do after you've plugged in x and y is that you're going to solve this new equation that you have for a. All right, so from here, you're going to solve for a, or just get a by itself. All right. Well, to get a by itself, you need to divide by b squared. I know this is looking goofy, but hang in there with me. I have 3 over b squared equals a. Okay. I've taken that equation that I created, I isolated a, so now I have this. I have an expression for a. All right. So now we're just going to leave that b, and we're going to try to kind of start from scratch again. So let's switch colors here. I'm going to repeat that process. I'm going to go back to where I started. Okay, so I'm going to get my equation, y equals ab to the x. I'm going to repeat that process, but maybe you can guess what I'm going to say. I'm going to do it with the other point, the one that I didn't choose initially. I'm going to take those x and y values, and I'm going to plug those ones in for x and y. All right, so I'm going to have 27 equals a times b to the 4th power. So I'm just replacing x and y with those coordinates. All right. And now I have another tool, I have another thing that I could plug into this equation, right? Because I know what a is. I know what a is. So I can take a, I have an expression for a, and I can plug it in for a in this equation. So I'm going to plug in this new expression that I've created for a. So let's see what it looks like. 27 equals, I'm taking 3 over b squared and substituting it in for a. So it's 3 over b squared times b to the 4th power. All right, so that looks weird. I know it looks weird, but I promise it's going to resolve here. Think about this as a fraction. Think about b to the 4th as b to the 4th over 1, right? If you think about it as a fraction, well, you can multiply these things. You're just multiplying fractions now. You multiply the tops, and you multiply the bottoms. So 3 times b to the 4th is 3b to the 4th. And b squared times 1 is just b squared. Okay, so I kind of just thought about b to the 4th as a fraction, put it over 1. You can do that with any expression. And then I just multiplied them, top and bottom, and it's resulted in this. All right, we can simplify that thing. We can simplify that thing and see what it ends up being. I have b to the 4th. I have, oh boy. Oh boy. Oh, there we go. Man, that was a panic situation. Good thing I'm going to get like almost 60 views on this so you guys can all see me mess up. All right, I got b to the 4th over b squared, okay? If you divide those things, remember you subtract the exponents when you divide, so that is 3b squared, right? Now you can see that we can solve this for b. We can solve this for b pretty easily. Divide by 3, that's 9 equals b squared. Take a square root, and that's 3 equals b. Okay, so now let's think about where we're at. I have b. I'm trying to write an equation that looks like this. This thing is going to make me lose my mind. I'm trying to write an equation that looks like this. ab to the x. I have b. I still need a. Okay, well, we can go back to this thing that we created at the beginning. That's an equation for a. And I know what b is, right? B is 3. So let's take b, plug it into this. It's 3 over 3 squared. Just replace b with 3, because that's what it is. And then we can solve it. 3 squared is 9. So that's 3 over 9. And if I simplify that, that's 1/3. So there you go. We have a and B, okay? So now I got both my pieces, and I can plug them in to the equation to make it look like this, ab to the x. All right, so let's do it down here. The general form is this, ab to the x. I know what a and b are, so it is y equals 1/3 times 3 to the x power, okay? Notice how 1/3 is not getting raised to the power, only 3. 3 is the base, right? 3 is b, that's the base. So here's my equation. You might be wondering, Mr. Smith, how come you didn't do plus minus when you took a square root when you were solving for b? Well, that's because in an exponential equation, I don't want negatives in the base, right? I don't want negatives, so I only take the positive. I only take the positive value. All right, well, if you are still watching this video at this point, that means you are the cream of the crop, as they say, okay? So if you are still watching this video, I want to reward you for being the cream of the crop. So when I'm back tomorrow or Tuesday, here's what you're going to do. When you come into class, you're going to come up to me and you're going to do two things. You're going to shake my hand and you're going to say the following, okay? You're going to shake my hand and you're going to say, Mr. Smith, the prawn yawns at dawn. The prawn yawns at dawn, okay? Shake my hand and say, the prawn yawns at dawn. And if you do those things, I will know that you watched the video through the end, and I will reward you with some fruit snacks, okay? So there you go. Congratulations for making it this far.